Okay, my fellows. Um, in my previous video, I explained why mass balance is very important in chemical engineering, especially dealing with a complex process. You need to balance each and every component to make everything has tally. And there's no any problem, there's no any error or measurement error in order to be able to estimate the efficiency of your process. So in mass balance, we deal with two things: the total mass balance and the component mass balance. So in my previous video, what I did or what I explained is simple: the total or the is the total mass balance added, where I'm able to explain whether a mass is conserved, is a balance or not. So on this video, I want to try to show you how to balance the component mass balance from this video. Okay, so let's begin. So we can see the schematic diagram that I did. You can see you have two stream M1 is M1, M2, M2, M4. And everything here we are dealing with salt solution, salt and water. So you can see our M1 has an incoming flow rate to be 20 kilogram per hour. And from that, 0.6 of the fraction is what? Water. So if you want to calculate the weight, it's simple: multiply 0.6 by 20. Simple from this equation that I wrote here. Fraction, simple: weight over total weight. The total weight is the 20. So if you know the fraction, is that cross multiplication so that you get the weight. And at the stream 2, we also have the total incoming flow rate to be what? 15. And and that 15 consists of salt and water. So if you know the fraction of water, we can know the other by simple from percentage or fraction. If you have two things, they add up to either 100 or 1. So from that, you can do that to estimate, no estimation, to calculate the percentage or the fraction of other. So we are going to use the principle of mass balance and fraction combined here. Okay, so let's calculate the fraction at each and every one of the stream before we can proceed to do our total mass balance and the company mass balance. Okay, okay. The question will have been simple if we know our M4, if we know the value of our M4. But because we don't know, so we have to use the principle of mass balance to calculate that principle of the total mass balance, to calculate that. After that, then we can calculate this here by using the we use the principle of total mass balance to calculate M4, and we use the principle of components mass balance to calculate for the weight of the water from the stream by balancing the weight from each and every stream to make sure that we get the component here, here has to be equal to here and here so that we can do our balances very well. Balancing means making things equal. Yeah, it's simple English. To balance things is to make things equal or to make sure things are conserved. Okay, so let's begin to calculate the fraction of salt from the M1. So we know the two types of M2. So M1 plus M2 is simple, add up to 1. So we know our M1 2.6 plus M2 is equal to 1. Now M2 is simple, the difference between zero point 0.6 and 1. 1 minus 0.6, which is simple, zero point 0.4. So here is what? 0.4 there. So we use the same idea. Two things added up to be 1. So here is what will be 0.6. But here is 0.4. But here we don't have to do with that also because it's pure water. Everything coming out from this stream is what? Purely water. So the salt here, simple 0. There's no salt from that stream. And because we don't know the mass balance of this, we cannot use the principle of fraction so that we multiply this to this to get this. So to be able to tackle or calculate the individual components, you have to use the principle of mass balance. So this how, so this is where the importance of the component mass balance plays out here. So let's write our, to calculate the M4 first, we first have to calculate or balance the total mass balance. But we have two things, total mass balance and the component mass balance. So we can use the total mass balance to calculate for that M4. After getting that, then simple, we can calculate the component from that straightforward. So let's start. So we say ME is equal to M out if there is no reaction and the processor is running under steady state. There's no leaking. Our estimation or our calculation, everything is what's right. So we can use this idea of, this idea comes out from the mass, from the conservation of mass balance. How we you can recall that we have already derived this. So we can say M1 is equal to M2. Our in is what, simple M1 plus what, M2, which is equal to our out, which is M3 plus what, M4. We know our M1 to be 20 plus our M2 to be 15 has to be equal to our M3, which is 12 plus M4, we don't know. So 35, summation of 20 plus 15 is 35, is equal to 12 plus our M4. So our M4 will be simple, the difference between 35 and what, 12. So which is simple 23. Alright, so I'll continue in the part 2 of this video. So see me part 2 of this video.